So what is the reason behind finding the prime factorization? Why do we even care about finding a number's prime factorization? So what we've discovered so far is we've learned using our sieve, we've learned what numbers are prime and which ones are composite, right? Now, if I were to say I want to find the greatest common factor, meaning the biggest number that goes into two different numbers. So if I have the numbers 8 and 6, and I want to know their greatest, oops, can I spell greatest? I combined great and est into one word. The greatest, oh, that is one word, greatest common factor. Well, what are the factors of 8? So we already know the prime factorization of 8, don't we? What are the factors of 8? 4 times 2, and then keep breaking it down. 2 times 2. So 8 is equal to 2 times 2 times 2, or 2 to the third power. 6, what are the factors of 6? 3 and 2. 3 times 2. So 6 is equal to 3 times 2. What do they have in common? 2. So the greatest common factor is 2. The GCF, that's what we call it, the GCF, is 2, because both 2 go into 8 and 6. And we can use the prime factorization, or we can list all the factors. Either way, that's how we're going to find the greatest common factor, the biggest number that goes into both. Okay, so those numbers weren't as complicated. Let's say I wanted to find the greatest common factor between 42. 42 and what? You always have to have between two different numbers. 42 and 30. I love it. Okay? We would need to either list all the factors of 42 or find the prime factorization. Sometimes you're going to have a preference. Which do you like doing better? The factor tree? So let's go factor tree. 42, who can tell me two numbers that multiply together to give us 42? 7 times 6, right? And 30 is, I didn't even go all the way, did I? 2 times 3. So 7 times 2 times 3 is equal to 42. What about the factors, the greatest common factor, or sorry, the factors of 30? It's 10 times 3, right? 10 times 3, good. And we could break down 10 even further. 2 times 5. So 30, I'm running out of space here, but 30 is equal to 5 times 2 times 3. Do you see where I'm getting those numbers from? What is the thing that what's the greatest factors that they have in common? Yeah, 2 and 3. What's 2 times 3? 6. So the greatest common factor of 42 and 30 is 6. The GCF of 42 and 30 is 6. Because they shared 2 and 3, right? And 2 times 3 is 6. Yes. Because that's what factors are. Factors are the little pieces. The way I help people remember factors sometimes is you think about a factory, right? Here's a factory with its little smokestack. Maybe it's the one that I was talking about earlier that smells bad when you go by it. Factors, what do they produce? They produce products, don't they? Factories. A factory produces products. They have little pieces. 7 times 2. Those are actually prime factors, but these two numbers multiply together to give us 14. The product is the answer to a multiplication. So the factors are the little pieces that we multiply together to get that product. Okay, so the factors of 42, or the prime factors that we found over here, are 7 times 2 times 3. That's the prime factorization of 42. Prime factorization of 30 is 5 times 2 times 3. And then we're multiplying 2 times 3 because that they both have 2 and 3 in common. And 2 times 3 is 6. So that means their greatest common factor is 6, yes. Because we want to know the biggest number that goes into both. If I just said 2 goes into both, then that's not big enough, right? 3 goes into both, but because 2 times 3 is 6, 6 is the greatest common factor. I mean, you could say 2 times 3, but then people are like, well, what's that? It's just more simple to say 6, right? Even though it's not a prime factor, it doesn't matter. It's the biggest number that divides evenly into both. Yes. And the reason why we're doing all of this work with greatest common factor is because we're going to use that to reduce fractions. If I have the fraction 30 over 42, and I divide the numerator by 6, and I divide the denominator by 6, I'm going to get 6 goes into 30 5 times, 6 goes into 42 7 times, and that's how we simplify fractions. So we use the greatest common factor to see what can I divide in. Now, if we didn't know right away, you can always go step by step. You could say, well, both of those numbers are even. Let me divide them by 2. Divide this one by 2, divide this one by 2. 2 over 2 is the same thing as 1, right? So 30 divided by 2 is 15. 42 divided by 2 is 21, and then we could ask ourselves, is there a number that goes into 15 and 21 evenly? 3. So I divide this number by 3, I divide this number by the same 3, and I get 5 over 7. So the greatest common factor took me there faster, but it doesn't matter, I can just still go one step at a time. They're always going to be the same equivalent fractions. Okay, is that making sense here?